of Examsnet. Welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. Let's start this session. Here is a question. What is the modulus of the complex number cos theta plus I sin theta upon cos theta minus I sin theta, where I is equals to under root of minus 1? This is a question from complex number. Now let us solve this. Let z is equals to cos theta plus I sin theta upon cos theta minus I sin theta. Now rationalizing it, it will be cos theta plus I sin theta upon cos theta plus I sin theta. Further solving it, we will get cos theta plus I sin theta whole square upon cos square theta minus I sin theta square. Again solving, we will get cos 2 theta plus I sin 2 theta upon cos square theta plus sin square theta. We know the value of cos square theta plus sin square theta is 1. So the remaining term will be cos 2 theta plus I sin 2 theta. Now we have to find the modulus of z. This is the value of z. Therefore, the modulus of z will be under root of cos square 2 theta plus sin square 2 theta, which will be equals to 1. So 1 is the correct answer for this question. Next question is, consider the proper subsets of 1, 2, 3, 4. How many of these proper subsets are the superset of the set 3? We know that the number of the proper subset of any set of n elements is 2 to the power n minus 1. This is a very basic question from the chapter sets. So the given set here is 1, 2, 3 and 4. Can you tell me what is the value of n? Yes, n is 4. So the number of proper subsets for this will be 2 to the power 4 minus 1, which is 15. Now let us see the proper subset. The elements of the proper subset will be 1, 2, 3, 4, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4 and 5. You know that 5 is in every set. So these are the elements of the proper subset. Now we have to find that superset of the set 3 is. Now from the proper subset you can see the elements in which 3 is present. 1, 2, 3, 4, 5, 6 and 7. So we can say that the number of superset of 3 is 7. So we will write it as superset of 3 is 7. So the correct answer for this question is 7. Next question is, let P, Q and R be 3 distinct positive real numbers. If D is equals to PQR, QRP, RPQ, then which one of the following is correct? It is given that D is equals to PQR, QRP and RPQ. Now, further expanding these terms, we will get P into RQ minus P square plus Q into RP minus Q square plus R into PQ minus R square. I hope you are familiar with this step. We have just expanded this by removing the first row and the first column, then first row and the second column, and then first row and the third column. So now further solving this, we will get 3pqr minus pq minus qq minus rq. Now taking minus common, it will be pq plus qq plus rq minus 3pqr. Now for the real and distinct positive real value of p, q and r, this term will be greater than 0. So we can say that for real and distinct positive real value, minus of pq plus qq plus rq minus 3pqr is greater than 0. Now since this term is greater than 0, the expansion is greater than 0, therefore d will be less than 0. Since its expansion is greater, so therefore d will be less than 0. So the correct option is d less than 0. Next question is, what is the sum of last 5 coefficients in the expansion of 1 plus x to the power 9 when it is expanded in the ascending powers of x? This is a question from the expansion and binomial theorem. This type of question comes so many times in the exams, so you need to understand this very carefully. Now talking about the expansion of 1 plus x to the power 9, it will be equals to 9c0 plus 9c1x plus 9c2x square plus 9c3x cube plus 9c4x to the power 4 plus 9c5x to the power 5 plus 9c6x to the power 6 plus 9c7x to the power 7 plus 9c8x to the power 8 plus 9c9x to the power 9. This is the expansion of this term. Now we have to find the sum of last 5 coefficients. You can see that we have to find sum of last 5 coefficients. So the sum of last 5 coefficients is 9c5 plus 9c6 plus 9c7 plus 9c8 plus 9c9. So the values will be 126 plus 84 plus 36 plus 9 plus 1. These are the values that we will get after solving all these 5 terms. So the total will be 256. So the 256 is the right answer for this question. Next question is, consider the following in respect of a non-singular matrix of order 3. Which of the above statements is or are correct? Now let us see the statements. Statement 1 is A of adjoint A is equals to adjoint of A into A. We already know that this is a statement which is given in all the books. So we can say that statement 1 is correct. Now talking about the second statement. Second statement is determinant of adjoint A is equals to determinant of A. But we know that adjoint of A is equals to determinant of A inverse into determinant of A. It means that second statement is completely wrong, because we know the correct statement, which is adjoint of A is equals to determinant of A inverse into determinant of A. So we can say that statement 2 is not correct. The correct option for this is 1 only. Only first statement is correct for this question. Next question is, the center of the circle x minus 2a into x minus 2b plus y minus 2c into y minus 2d is equals to 0 is what? We have to find the center for this circle. So writing the equations, we will get x minus 2a into x minus 2b plus y minus 2c into y minus 2d is equals to 0. Now further solving it, multiplying it, we will get x square minus of 2 into a plus bx plus 4ab plus y square minus 2 into c plus d into y plus 4cd is equals to 0. This is the equation after multiplying the terms. Now I can arrange it in this form: x square plus y square minus 2 into a plus b x minus 2 into c plus dy plus 4 and in bracket AB plus CD is equals to 0. I have taken 4AB and 4CD as a single term, and you can see that 4 is common, so it will be 4 and in bracket AB plus CD. Now we know the general equation of circle. The general equation of circle is x square plus y square plus 2gx plus 2fy plus c is equals to 0. This is the general equation of circle. Now, for this general equation of circle, center will be equals to minus g comma minus f, and radius will be equals to under root of minus of g square plus minus of f square plus c. So on comparing this general equation with the given equation, we will get the values of center as g will be equals to minus of a plus b and f will be equals to minus of c plus d. On comparing this equation, we can see that g is equals to minus of a plus b and f is equals to minus of c plus d. So we can say that the center for this question is minus of minus a plus b and minus of minus c plus d. So it will be a plus b and c plus d. So this is the center for the given question. Next question is the point 1 comma minus 1 is one of the vertices of a square if 3x plus 2y is equals to 5 is the equation of one diagonal of the square, then what is the equation of other diagonal? We know that the diagonal of a square bisect each other perpendicularly, and the equation of diagonal is 3x plus 2y is equals to 5. It is given. Now, it is the equation of one diagonal of a square. So, the equation of the other diagonal, that is perpendicular to the given diagonal, will be 2x minus 3y is equals to k. Now, the points are 1 comma minus 1. The points 1 comma minus 1 does not lie on 3x plus 2y is equals to 5. Means the points 1 comma minus 1 does not satisfy the given equation of diagonal. So it means that the point 1 comma minus 1 must be satisfied for the diagonal 2x minus 3y is equals to k. So putting the values here, 2 into 1 minus 3 into minus 1 is equals to k. So it will be 2 plus 3. So the value of k is 5. Now putting this value in the equation of the other diagonal, the equation will be 2x minus 3y is equals to 5. So this is the equation for the other diagonal of the square. Next question is, if p x of y be any point on the ellipse 25x square plus 16y square is equals to 400, if q 0, 3 and r 0, minus 3 are the 2 points, then what is pq plus pr equals to? Let us first draw the ellipse. This is a question from conic sections, and conic sections are very important part to cover because so many questions comes from this part, and in the previous years also questions have come from conic sections. Now let us draw the ellipse. Let this be the ellipse, and the points will be, this will be the O, which is origin. let here be Q and let this be R. This is x-axis and this is y-axis. Now the equation of ellipse which is given in the question is 25 x square plus 16 y square is equals to 400, and we know the equation which is in the conic section is x square upon a square plus y square upon b square is equals to 1. So writing this in this form, it will be x square upon 16 plus y square upon 25 is equals to 1. Here a square is 16 and b square is 25. Now let us find the foci points. So we know that foci points is equals to 0 and plus minus BE. So it will be 0 and plus minus of under root b square minus a square. So it will be 0 and plus minus under root 25 minus 16, because the value of b square is 25 and a square is 16. So the points will be 0 and plus minus 3. These are the points of foci. Now let us locate this point. So the points will be 0 and 3 and 0 and minus 3. Now from the question, point P of x comma y lie on the ellipse. Then since it lies on the ellipse, then sum of its distance from two fixed point is always constant, or we can say equal to the length of its major axis. So we can write that PQ plus PR will be equals to 2 into 5, which is equals to 10. I hope it is clear to you. Since the question says that point P of x and y lies on the ellipse, it means the point somewhere lies on the ellipse, then the sum of its distance from two fixed point is always constant. Therefore, it will be equal to the length of its major axis, and the length of the major axis will be 4, 0 and again minus 4, 0. So we can say that PQ plus QR is equals to 2 into 5, which is 10. Next question is, if the circumference of the triangle formed by the lines x plus 2 is equals to 0, y plus 2 is equals to 0 and kx plus y plus 2 is equals to 0 is minus 1, then what is the value of k? Again you can see that this is a question from equations, and we are very well familiar how to solve equation of two sides of a triangle. We know that the given equations are x plus 2 is equals to 0 and y plus 2 is equals to 0. These are the equations of two sides of triangle. They intersect at a right angle. Thus, the triangle that will be formed by them will be a right angle triangle. Now let us understand this by the diagram. So let us assume that this particular will be our right angle triangle. Let us name it A, B and C. This is the right angle triangle, and here there will be x plus 2 is equals to 0 and here there will be y plus 2 is equals to 0. And third equation is kx plus y plus 2 is equals to 0. I hope you are having no doubts with this diagram. It is very clear. This is the y-axis and this is the x-axis. Now we know that circumcenter of the right triangle lies on its hypotenuse. This is the hypotenuse AC, and the circumcenter of the right triangle lies on its hypotenuse. So the circumference for the points -1 and -1, which is given in the question, should lie on this equation kx plus y plus 2. The points are given in the question, which is -1, -1. So we know that it won't lie on the y plus 2 is equals to 0 and x plus 2 is equals to 0. Therefore, the points should lie on kx plus y plus 2 is equals to 0. Since it lies on kx plus y plus 2 is equals to 0, it means that it will also satisfy the equation. So, putting the points in this equation, we will get k into -1 plus -1 plus 2 is equals to 0. So, the value of k will be 1. See, these are very simple question. You just have to remember all the basic concepts of equations of triangles, and if a triangle is having equation of two sides. Next question is, in a parabola y square is equals to x, what is the length of the chord passing through the vertex and inclined to the x-axis at angle theta? This is a question from conic sections, and conic sections consist of many questions that comes continuously in the exams. In the year 2017 also, this type of question has already come. The given equation of parabola is y square is equals to x, and we know the standard equation of parabola. Can you tell me what is the standard equation of parabola? Standard equation of parabola is y square is equals to 4ax. So, we can say that focus is always a comma 0, and from here we can find the value of a, which will be 1 by 4. Now, let us understand this by a diagram of parabola. According to this question, the parabola will be here. So, this will be our parabola, and there is a line which passes through it, which will be like this. It is a line that passes through given parabola. See, it is a rough diagram just to make you understand. Now, this is the angle which is formed by this line, which will be theta, and parabola is y square is equals to x. We can write it. This is x-axis, this is y-axis, this is the origin, so it will be 0, 0. Now, we have found the value of a, and we know that focus is a, 0. So, we can also mention the focus. Focus is 1 by 4, 0. Now, we know that focus of parabola y square is equals to x is 1 by 4 and 0. So, vertex of parabola is 0, 0, which is here. Now, let the points P of t square upon 4 and t by 2 lie on the parabola. Then, let us see what happens when P of t square and 2t lies on the parabola. If this point lies on the parabola, then the slope will be equal to tan theta. This is a very basic concept for parabola, that slope is equals to tan theta. Now for these 2 points, slope will be t by 2 upon t square by 4 is equals to tan theta. I have written the slope using these 2 points. So again solving, we will get t is equals to 2 cot theta. So we have got the values for point P, which is t square by 4 and t by 2. It will be equal to cot square theta and cot theta. Now we have to find its distance from the vertex 0, 0. Means we have to find the distance from the vertex. Vertex is here. The distance from the vertex to the point P, t square and 2t. We have to find the distance here. So for the distance, the formula is under root of cot square theta minus 0 whole square plus cot theta minus 0 whole square. This is the formula for distance. Further solving it, we will get cot theta under root of cot square theta plus 1, which is equals to cot theta into cosec theta. We know that under root of cot square theta plus 1 is cosec theta. So, this will be the correct answer. I hope you are clear with this question. See, here there will be cosec square theta. Because we know that under root of cot square theta plus 1 is cosec square theta. So this is the correct answer for this question. Next question is, under which conditions are the points A, B, C, D and A minus C and B minus D collinear? So the points are given A, B, C, D and A minus C and B minus D. It is asked that under which condition this points will be collinear. We know that any 3 points are collinear only if determinant is 0. So let us find the determinant for this 3 points. So it will be A, B, C, D, A minus C, B minus D, and here it will be 1, 1 and 1. Now we have to prove that this is equals to 0. Then only these 3 points will be collinear. So on expanding further, it will be A into D minus B plus D plus B into A minus C plus 1 into C into B minus D into A minus C is equals to 0. We have expanded it first by removing the first row and the first column, then by removing the first row and the second column, and then by removing the first row and the third column. Further solving, we will get 2AD minus AB plus AB minus 2BC plus BC minus AD is equals to 0. Now, further it will be on simplification AD minus BC is equals to 0. So, we can say that AD is equals to BC. So, since AD is equals to BC, this points will be collinear on this condition. So, under AD is equals to BC, this points will be collinear. Next question is, let ABC be a triangle if D 2, 5 and E 5, 9 are the midpoints of the sides AB and AC respectively, then what is the length of the side BC? Again, this is a question from triangle. So, it is very important that you are very aware of all the properties of triangle and all the formulas that are used in the triangle. Now, the points are D 2, 5 and E 5, 9. It is given that this both are the midpoints of side AB and AC, but we don't know the side. So first let us make the diagram. It will make us easier to understand this question. Let this be a triangle ABC. Now midpoints of AB and AC means here and here. So let us draw a line joining the midpoints. So name them D 2, 5 and E 5, 9. I hope now it is clear to you. These both are the midpoints. Now, since these are the midpoints of AB and AC, then we can write that 2 into DE will be equals to BC. Means DE is half of BC. So, BC will be 2 into DE. Now, let us find the value for BC. So, BC will be equals to 2 into under root of 5 minus 2 whole square plus 9 minus 5 whole square. This is the value of DE. So, further solving it, it will be under root of 3 square plus 4 square, which is equals to 2 into 5, which is equals to 10. So, this is the length of side B, C. We have used the midpoint formula to solve this question. Next question is, if the foot of the perpendicular drawn from the point 0, k to the line 3x minus 4 minus 5 is equals to 0 is 3, 1, then what is the value of k? First, let us understand this question by a simple diagram. A line is given which is 3x minus 4y minus 5 is equals to 0. So this is the line, and a perpendicular is drawn from the point 0, k. It is written in question that a perpendicular is drawn and the line is 3x minus 4y minus 5 is equals to 0. So the points of the line is 3, 1. It is given in question. So this is our diagram. I hope it is clear to you. Now the slope of the line 3x minus 4y minus 5 will be m is equals to 3 by 4. The slope will be 3 by 4. So slope of any perpendicular line to 3x minus 4y minus 5 is equals to 0 will be m dash is equals to minus 4 by 3, which is the reverse. If slope of 3x minus 4y minus 5 is 3 by 4, then the slope of any line perpendicular to it will be its reverse, means minus 4 by 3. Now the required line passes through the points 0, k and 3, 1. Means the line which is required, it will pass through 2 points, which is 0, k and 3, 1. So it will be k minus 1 upon 0 minus 3, which gives minus 4 by 3. So from here we can get the value of k, which will be 5. We know that this is the slope, minus 4 by 3 is the slope for the perpendicular line, and for the perpendicular line point is 0, k. So that is why it is equals to minus 4 by 3. So in this way we get the value of k, which is 5. Next question is, what is the obtuse angle between the lines whose slopes are 2 minus root 3 and 2 plus root 3? It is a very simple question. In this question, two slopes are given. M1 is equals to 2 minus root 3 and M2 is equals to 2 plus root 3. We have to find the obtuse angle between them. So the obtuse angle will be theta is equals to tan inverse M1 minus M2 upon 1 plus M1 into M2. We already know the value of M1 and M2. So putting the value of M1 and M2 here, we will get tan inverse 2 minus root 3 minus 2 minus root 3 upon 1 plus 2 minus root 3 into 2 plus root 3. Further solving, we will get tan inverse minus 2 root 3 upon 2, which is equals to tan inverse minus under root 3, which will be equals to 120 degree. So this is the angle between the slopes. It is an obtuse angle because it is greater than 90 degree. So the correct answer is 120. Next question is, if 3x minus 4y minus 5 is equals to 0 and 3x minus 4y plus 15 is equals to 0 are the equations of a pair of opposite sides of a square, then what is the area of a square? Two equations are given, which is 3x minus 4y minus 5 is equals to 0 and 3x minus 4y plus 15 is equals to 0. These are the equations of a pair of opposite sides of a square, and we have to find the area of a square. Now we know that opposite sides of square are parallel. So the distance between two parallel sides is equal to the side length of the square. So we have to find the side length of the square. So side length of square will be, see, it is a very basic concept that if pair of opposite sides of a square are parallel, then distance between those parallel sides is equal to the side length of the square. So the side length of the square will be mod of 15 minus minus 5, which is the constants here, c, upon under root of 3 square plus 4 square. Further solving it, it will be 20 upon 5, which is 4 units. Now this is a single unit. We have to find the area of square. Area of square is 4a square. So area will be 4 into 4, which is 16. We know that area is 4a, means 4 into a. So the answer is 16. Next question is, the directions are given which will be followed up to question number 18. Let a sin square x plus b cos square x is equals to c, and b sin square y plus a cos square y is equals to d, and p tan x is equals to q tan y. These are the three most important things which are given in the question. We have to remember these three equations. Now in this question we have to find what is tan square x equal to. So let us take the first equation, which is 1 a sin square x plus b cos square x is equals to c. Now a sin square x plus b cos square x is equals to c into sin square x plus cos square x. I can write it here because we know that the value of sin square x plus cos square x is 1. So if I write it also, it is equal to c only. So further solving, we can get a minus c sin square x is equals to c minus b cos square x. What we have done is we have separated sin square x on the left hand side and cos square x on the right hand side. So from here I can get the value of sin square x upon cos square x, which will be equals to c minus b upon a minus c. Now you can see that sin square x upon cos square x is equals to tan square x. So the value of tan square x is c minus b upon a minus c. So the correct option for this question is option number A, which is c minus b upon a minus c. This is the value of tan square x. Next question is, see, here the directions are same as the previous question. In this question we have to find what is d minus a upon b minus d equal to. So now in the last question we have used this term. Now let us use the second equation. The second equation is b sin square y plus a cos square y is equals to d. Again I can write it as b sin square y plus a cos square y is equals to d into sin square y plus cos square y, because we know that sin square y plus cos square y is 1. Now from this we can get b minus d into sin square y is equals to d minus a into cos square y. We have just separated the terms of sin square y on the left hand side and the terms of cos square y on the right hand side. So from here we can get the value of sin square y upon cos square y, which is equals to d minus a upon b minus d. Now again sin square y upon cos square y is tan square y. Therefore tan square y is equals to d minus a upon b minus d. And in the question we have to find the value for d minus a upon b minus d. So the value is tan square y. See, this type of questions are very simple when the directions of three questions are same. Again the directions are same, but in this question we have to find what is p square upon q square equal to. So now let us use the third part, which is p into 10x is equals to q into 10y. Now squaring both the sides, we will get p square 10 square x is equals to q square 10 square y. Now we can say that p square upon q square is equals to 10 square y upon 10 square x. And in the previous two questions we have already found the value for 10 square y and 10 square x. So it will be d minus a upon b minus d upon the value of 10 square x is c minus b upon a minus c. We have already found these values in the previous questions. So further solving it, it will be d minus a upon b minus d into a minus c upon c minus b. So further solving, it will be a minus d into c minus a upon b minus c into d minus b, which is the value for p square upon q square. This is the question which have directions which will be also used in the coming two questions. Here a value is given which is Tn is equals to sin n theta plus cos n theta, and we have to find the value of T3 minus T5 upon T5 minus T7. So since Tn is equals to sin n theta plus cos n theta, here n can be any number. So we have to find the value for T3 minus T5 upon T5 minus T7. So we just have to put the values in this particular part. So for T3 it will be sin 3 theta plus cos cube theta plus minus, because it is T3 minus T5. T5 will be sin 5 theta plus cos 5 theta upon, now can you tell me what will be the value for T5 minus T7? Yes, the value will be sin 5 theta plus cos 5 theta minus sin 7 theta plus cos 7 theta. So it is a very simple concept. You just have to put 3 and 5 and 7 in place of n here. So again solving further, we will get sin cube theta common. So the remaining terms will be 1 minus sin square theta, and again we can take cos cube theta common. So the remaining terms will be 1 minus cos square theta. Now let us see the denominator part. From denominator we can take sin 5 theta common. So the remaining terms will be 1 minus sin square theta. Also we can take cos 7 theta common. So the remaining terms will be 1 minus cos square theta. Further solving it, we will get sin cube theta into cos square theta, because we know that 1 minus sin square theta is cos square theta, plus cos cube theta into sin square theta. Similarly, 1 minus cos square theta is sin square theta. Then sin 5 theta into cos square theta plus cos 7 theta into sin square theta. Further solving this, we will get sin square theta into cos square theta and sin theta plus cos theta upon sin square theta into cos square theta, and the remaining terms will be sin cube theta plus cos cube theta. You can see that in this part sin square theta is common in both the terms, and in denominator part sin square theta into cos square theta is common. So we have taken common. Now since this both are equal, this will be cancelled. So the remaining part will be sin theta plus cos theta upon sin cube theta plus cos cube theta, which is equals to T1 upon T3. You can see that T1 will be sin theta plus cos theta and T3 will be sin cube theta plus cos cube theta. So the answer is T1 upon T3. Now let us look at the second part of this question. In this part we have to find the value of T1 square minus T2. Again let us write that Tn is equals to sin n theta plus cos n theta. Now can you tell me what will be the value for T1 square minus T2? For T1 square, it will be sin square theta plus cos square theta plus 2 sin theta cos theta. I hope it is clear to you, because when we keep sin theta plus cos theta whole square, it will be equal to sin square theta plus cos square theta plus 2 sin theta cos theta. Since there is T1, so value of T1 will be sin theta plus cos theta, and there is square, so sin theta plus cos theta whole square. Again, minus T2 will be sin square theta plus cos square theta. So further solving this, we will get 1 plus sin 2 theta minus 1, which is equals to sin 2 theta. So the value for T1 square minus T2 is sin 2 theta. Next part is, what is the value of T10 where theta is equals to 45? Now we have to find the value of T10. We know that Tn is equals to sin n theta plus cos n theta. We have to find the value for T10. So T10 will be equals to sin 10 theta plus cos 10 theta. Here the value of theta is also given in the question, which is 45. So let us keep it sin 10 45 plus cos 10 45. So the values of sin 45 will be 1 upon root 2 and the power is 10. Again cos 45 is 1 upon root 2 and the power is 10. You can see there is 1 upon root 2 plus 1 upon root 2. It will be 2 into 1 upon root 2 and the power will be 10. Again simplifying it, it will be 2 into 1 by 32, which is equals to 1 upon 16. So the value of T10 is 1 upon 60. Next question is, read the following information and answer the 3 items that follow. Again the directions for 3 questions are same, and the given values are alpha is equals to beta is equals to 15 degree, means alpha and beta are both equal and they are equals to 15 degree. We have to find the value for sine alpha plus cos beta. Now sine alpha plus cos beta will be equals to root 2 1 upon root 2 sine alpha plus 1 upon root 2 cos alpha, since alpha and beta are equal. Further solving, it will be equal to root 2 sine alpha cos 45 plus cos alpha sine 45. We know that the value of cos 45 is 1 by root 2 and the value of sine 45 is also 1 by root 2. So in place of these two terms, I have written cos 45 and sine 45. Now further solving, it will be root 2 sine alpha plus 45. It is the formula for sine A plus B. Sine A cos B plus cos A sine B. Now further solving, it will be root 2 sine, now putting the values for alpha, alpha is 15 plus 45. So it will be root 2 sine 60 degree. Can you tell me what is the value of sine 60? The value of sine 60 is root 3 by 2. So it can be written as root 2 into root 3 upon root 2 into root 2. So this root 2 and root 2 will be cancelled. So the answer will be root 3 by root 2. Next part of this question is, what is the value of sine 7 alpha minus cos 7 beta? Sine 7 alpha minus cos 7 beta. We know the value of alpha and beta, which is 15. So we'll simply put it here, sine 7 into 15 minus cos 7 into 15. Now it will be sine 105 minus cos 105. Now we can write it as 90 plus 15. We can write 105 as 90 plus 15. Similarly, here also we can write it as 90 plus 15. So this makes a formula which is sine 90 plus theta is cos theta. So it will be cos 15 minus cos 90 plus theta is minus sine theta. So it will be minus sine 15. Further solving, it will be cos 15 plus sine 15. Now we already found the value for cos 15 and sine 15 in the previous question, because in the previous question we found the value for sine alpha plus cos beta and the value was root 3 upon root 2. Now alpha and beta is 15, so therefore the value for cos 15 plus sine 15 will be also root 3 upon root 2. So there is same answer for both the questions, root 3 upon root 2. Next part of this question is, what is sine alpha plus 1 plus cos beta plus 1 equals to? Let us solve this. See, before solving, you can see that all these questions are from trigonometry. Trigonometry is very important topic in mathematics, and trigonometry is useful only when you know all the derivations and all the formulas properly. Trigonometry requires nothing. It is very simple only if you know all the formulas for sine, cos, tan, cot, etc. So now coming to the question, we have to find the value for sine alpha plus 1 plus cos beta plus 1. In the first part of this question, we have solved sine alpha plus cos beta. So similarly, this will be equal to root 2 into 1 upon root 2 sine alpha plus 1 plus 1 upon root 2 cos beta plus 1. It is same as the first part. So further solving, it will be root 2 into cos 45 into sine alpha plus 1 plus sine 45 into cos beta plus 1. See, it is the same steps. In this step, what I have done is I have multiplied and divided this term by root 2. And after that, I know that the value of cos 45 is 1 by root 2 and the value of sine 45 is 1 by root 2. So just replace the values. Further solving, it will be root 2 sine alpha plus 1 plus 45. Now, further solving, putting the value of alpha here, it will be root 2 sine 15 plus 1 plus 45, which will be equal to root 2 sine 61. Now let this be equation number 1. Let this be equation number 1, and again looking at the part 1 upon root 2 into root 3 cos 1 plus sine 1, it will be equal to 2 upon root 2 into root 3 by 2 cos 1 plus 1 by 2 sine 1. Here I have multiplied and divided by 2. So further solving this, it will be equal to root 2 sine 60 cos 1 plus cos 60 sine 1. See, again the value of cos 60 is 1 by 2 and the value of sine 60 is root 3 by 2. So we have just replaced the values. So further it will be root 2 sine 61. Let this be equation number 2. Now you can notice a thing that equation number 1 and equation number 2 is equal. So we can say that the answer for this question is 1 upon root 2 root 3 cos 1 plus sine 1. This is the correct answer for this question, since both the equation 1 and equation 2 is equal. Next question is, if sin x plus sin y is equals to cos y minus cos x, where x and y lies between 0 and pi by 2, then what is the value of 10x minus y by 2? So first let us write what is given in the question. Sin x plus sin y is equals to cos y minus cos x. It is given. So it can be written as sin x plus sin y upon cos y minus cos x is equals to 1. Now applying the formula for sin A plus sin B and cos A minus cos B. On applying formula, it will be 2 sin x plus y upon 2 into cos x minus y upon 2. Upon, now denominator part is cos A minus cos B. So it will be 2 sin x plus y by 2 into sin x minus y by 2, and it is equals to 1. Now further solving it, we will get cot x minus y by 2 is equals to 1. Now we know that cot x minus y by 2 is 10x minus y by 2. So 10x minus y by 2 is equals to 1. And in the question we have to find the value for 10x minus y by 2. So the value of 10x minus y by 2 is 1. Next question is, if A is a matrix of order 3 into 5 and B is a matrix of order 5 cross 3, then the order of AB and BA will respectively be. It is given that A is a matrix of order 3 cross 5. Now tell me, what do you understand by order 3 cross 5? 3 cross 5 means 3 is for rows and 5 is for columns. Means we have a matrix in which there are 3 rows and 5 columns. So A is a matrix for I into J 3 cross 5. Again I is for rows and J is for columns. Similarly B is a matrix for 5 cross 3. So these are the two matrices which is given. Now let us look for the order of AB. AB will be equals to I into J and it will be 3 cross 3. And BA will be equals to I cross J 5 cross 5. See, in the question the order of AB and BA was asked. So the correct order of AB is 3 cross 3 and the order of BA is 5 cross 5. So the correct option is 3 cross 3 and 5 cross 5. Next question is, if P square, Q square and R square are in GP where P, Q and R is greater than 0, then which of the following are correct? The statements are P, Q and R are in GP and log of P, log of Q and log of R are in GP. Before moving on to this question, let us understand a basic concept that if P, Q and R are in GP, it means that it should satisfy an equation which is QR is equals to P into R. If QR is equals to P into R, then P, Q and R are in GP. So for the first statement, it means that we have to prove this part. Because if we prove this part, then P, Q and R are in GP. Now in the question it is given that P square, Q square and R square are in GP. Now since they are in GP, it means that Q square whole square is equals to P square into R square by the common concept. Now further solving it, it will be Q square is equals to P square into R square whole power 1 by 2. Then Q square is equals to P into R. Means we have found that Q square is equals to P into R. It means that P, Q and R are in GP. So we can say that the first statement is absolutely correct. Now for the second statement, now we already proved that Q square is equals to P into R. Now taking log on both the sides, log of Q square is equals to log of P into R. Further solving this, it can be written as 2 log Q, because we know that log A power M is equals to M log A. Similarly, log A into B is log A plus log B. So log P into R is log P plus log R. And this is the part which we have to prove. Since 2 log Q is equals to log P plus log R, we can say that log P, log Q and log R are in AP. So we can say that both the statements are correct. So the correct option for this question is both 1 and 2. Next question is, if cot alpha and cot beta are the roots of the equation x square minus 3x plus 2 is equals to 0, then what is cot alpha plus beta equals to? This is a question which comes from the chapter where we use sum of roots, product of roots, alpha, beta, gamma, etc. And this type of question comes many a times in exam, and this type of questions has repeatedly come in the previous question papers. So the given equation is x square minus 3x plus 2 is equals to 0, and it is given that cot alpha and cot beta are the two roots of the given equations. Now we have the roots, so we can find sum of roots. Can you tell me what is the formula for sum of roots? Sum of roots means simply adding both the roots. Cot alpha plus cot beta is equals to minus of minus 3, which is equals to 3. And sum of roots can be also written as minus b upon a. Now you can see in the equation that minus b is minus 3. So it will be minus of minus 3 upon a. A is 1. Therefore, sum of roots is equals to minus b by a. So sum of roots is 3. Now let us look at the product of roots. Product of roots is equals to c upon a. Now from the equation, c is 2 and again a is 1. So it will be 2 by 1, which is 2. Let this be equation number 2. Now we have to find the value for cot alpha plus beta. So cot alpha plus beta is cot alpha into cot beta minus 1 upon cot alpha plus cot beta. This is the formula for cot alpha plus beta. So now simply putting the values which we already found, sum of roots and product of roots. See, product of root means cot alpha into cot beta, this is the product, and cot alpha plus cot beta is the sum. So product of root is 2 minus 1. Again sum of roots is 3. So it will be 1 by 3. So the value of cot alpha plus beta is 1 by 3. It was a very simple question. Only the main part here was this formula, which is cot alpha plus beta. It is very important to remember all the formulas for trigonometry. Most of the students forget the formulas, therefore they find the questions very difficult. But if you remember formulas, it is very easy. Next question is, the roots alpha and beta of a quadratic equation satisfies the relation alpha plus beta is equals to alpha square plus beta square, and alpha into beta is equals to alpha square into beta square. What is the number of such quadratic equations? We have the relations alpha plus beta is equals to alpha square plus beta square, and alpha into beta is equals to alpha square into beta square. Now let us look at the relation alpha into beta is equals to alpha square plus into beta square. It can also be written as alpha beta 1 minus alpha beta is equals to 0. Now since this both the terms are equals to 0, so alpha beta will be 0 or alpha beta will be 1. So when alpha beta is 1, then the value of alpha is 1 upon beta. Or similarly you can do for beta also. Beta will be 1 upon alpha. Now again from the relation which is given in question, alpha plus beta is equals to alpha square plus beta square. Now putting the value of alpha here, which is 1 by beta. So 1 by beta plus beta is equals to 1 by beta square plus beta square. Again simplifying it, it will be beta square minus beta is equals to 1 by beta minus 1 by beta square. Further solving it, it will be beta into beta minus 1 is equals to beta minus 1 upon beta square. Again simplifying it, it will be beta minus 1 into beta minus 1 upon beta square is equals to 0. This is beta. Don't get confused. Further solving it, it will be beta minus 1 into beta cube minus 1 is equals to 0. So it can be also written as beta minus 1 into beta square plus beta plus 1 is equals to 0, which will be equals to either beta will be 1 or beta will be equals to minus of 1 plus minus root 3I upon 2, because this both the terms will be equals to 0. So in this case it will be beta is equals to 1, and in this case beta is equals to minus 1 plus minus root 3I upon 2. Again we know that alpha into beta is equals to 1. Then when beta is 1, then alpha will be 1 upon beta, which means 1. So therefore the roots alpha and beta will be now 1 and 1. And talking about when beta will be minus 1 plus root 3I upon 2, then alpha will also be equals to minus 1 minus root 3I upon 2. See, we have now talked about both the cases. When beta is 1, then alpha is 1, and when beta is minus 1 plus minus root 3I by 2, then alpha is minus 1 minus root 3I by 2. So we can say that the roots alpha and beta are equals to minus 1 plus minus root 3I upon 2 and minus 1 minus root 3I upon 2. These are the two roots, which is number of different quadratic equations. So the number of different quadratic equations is 2. Next question is, what is the argument of the complex number 1 minus I root 3 upon 1 plus I root 3, where I is equals to under root minus 1. This is a question from complex numbers. It is a different question. So let x plus iy is equals to the given complex number, which is 1 minus I root 3 upon 1 plus I root 3. Now rationalizing it, it will be 1 minus I root 3 upon 1 minus I root 3. Further solving it, it will be 1 minus I root 3 whole square upon 1 square minus I root 3 whole square. Further solving it, it will be 1 minus 3 minus I 2 root 3 upon 1 plus 3, which is equals to minus of 1 plus I root 3 upon 2. Now separating these terms, we can write it as minus 1 by 2 minus I root 3 by 2. I have just separated the denominator in two parts. So from here we can say that this was equals to x plus iy. So the value of x is minus 1 by 2 and the value of y is root 3 by 2. Therefore x is equals to minus 1 by 2 and y is equals to minus of root 3 by 2. Now we have to find the argument for the complex number. So the argument is tan inverse y upon x. So just putting the value of x and y here, tan inverse minus of root 3 by 2 upon minus of 1 by 2. Further solving it, it will be pi plus tan inverse root 3, which is equals to 180 plus 60, which is equals to 240. So the argument for this complex number is 240. I hope all these questions are clear to you, and keep learning and keep scoring high.